all before, but during the sports recommendations process, it's always awkward for you all because for some reason they treat you like little veal down in 10. And this year, rubber hits the road and things get a little bit more serious in terms of expectations and performance and what the grade is and what your future trajectories are going to be. So what we need you to understand, I guess, is twofold. And I think I told all of you this, but I'm not 100% sure. Number one is we went through we discussed, we all met, right? You came up at some point and told me what course you wanted to take for next year, is that right?
Yeah.
Okay. I went in yesterday. Well, you were at your UN stuff, or no, I didn't think we missed it, did we? Okay. Well, you guys, yesterday during that UN, one of those periods, I went through and filled out what your individual recommendations for the next year are. Understand that we'll always look to reevaluate at 30 weeks. Some of you that may have wanted to go through and do or selected pre-calculus might say, well, you know what, I've actually been improving my performance, or I thought about it and I want to go into this field, so is it possible to take pre-calc enriched? And if the marks are there, I see no problem. The other end of it is some of you might go the other end and say either, my marks fell off a little bit and or I don't have the time to manage it, or it's not really it doesn't relate to what I'm going to school for, so I'm just going to take pre-calculus regular. It doesn't matter. We don't get I don't get, some sort of performance bonus for you all going through and signing up for pre-calc enriched. I don't sell, used power suit. You've got to understand, you've got to take the course that's going to allow you to be successful within reason. Because the other end of it is, some of you just have, I see those of you that play 3 or 4 season sports. It's a ton of time away. Some of you go through and are involved in a bunch of extracurriculars, music, whatever. And if it's not something that you get fired up to do, it's going to be a drag for you. And if you're going, if you want to be a painter, is BC calculus on your radar? Probably not. It's not to judge. It very well may be. You may love numbers and say, yeah, you know what? I know I don't perform like I don't have a 99 in class, but I really do like getting challenged. And this class, while my marks might be a little bit lower, I think is more stimulating. And that's fine too. You can pick whatever you want. The other end of it is I recommended every one of you for AP statistics and every one of you for an introductory comp sci class. Some of you that have already taken a comp sci, please understand it was a blanket recommendation. All of you, especially those of you interested in going into some form of biomed field, I really encourage you to take AP Stat. The statistics that we do in 11 are a good introductory to what AP Stats is going to be about. And actually, from the people at the College Board, the AP Stats results more closely correlate to an AP English exam than they do an AP Calculus exam. So understand that. There is a bunch of reading in it, but it's like reading for me, being like, yeah, in this situation, this happens. And in this situation, this happens. So you read and say, yep, this is case A, or this is case B, and this is how we would approach it. I was never good at statistics because I am in the 3rd or 5th percentile for making sense from reading. I'm sure. So I was never good at AP Stat, but I had to take it when I was in college, which is even harder because you're covering the same amount of material in less classes with people who really, really don't care about how well you do. The other end is I'd advise you all to take some form of comp sci. It's a half-year class. If you don't like it, you don't have to take the second half. But the other end of it, it opens up so many careers for you in the future. And the last thing, in terms of building out your resume to make sure you're as competitive as a candidate as possible, I would advise you all, at least my selfishness, to go through and give Math League a try. I sent out the Google Classroom code before. Did any of you go through and sign up for it or no? Did anyone look into it? I'm all for 30? Seriously? Talk about a terrible Christmas gift that you all gave me, right? Nothing. In any case, I advise you to do it for nothing more. There's 5 meets during the year, 3 are done, 2 still happen. They do one practice run together if you're interested in going. If you do one practice run together, you can see, and you don't have to compete in every topic. It's like you go in, I think it's a 90, no, it's like a 5 to 10 minute thing where you sit down and they give you 4 or 5 questions and they say, all right, here's this, solve this out. It's not even, some of the topics are easier than others, but everybody goes, and frankly, this is the part that some of you don't get. Everybody gets a varsity letter that goes. So some of you right now is talking to the kid in the other section. He's got 3-season athlete, JV, every level. If you go out from athlete, you're varsity athlete. So that's clear for everybody. So you could actually, it's sort of more than college. But in any case, there is one last thing that you should have gotten right before we started. We talked before. Did we go over your holiday projects from last holiday or not? Okay. So I compiled them all. I sent them out. I guess that this didn't go out to you all. I sent it all out to your through Infinite Campus, and I selected all of you, but for some reason it only goes to parents. Like I thought it would go to your Infinite Campus email, like address that's linked to that, or get some alert. But in any case, this is, I got 112 projects in. This is all 112 of them scanned. Now some of them make me want to read them more than others, like somebody has a pie on theirs, which obviously drew me in immediately. And then there's like this. That's not wonderful. It doesn't even matter, right? They could be like, the guy that gave me this is a big fat idiot. I hate everything about him, blah, blah, blah. But it looks nice. But in any case, some of them, I have to tell you, by the way, nice thing, the letter I, just so you realize, I don't know if you know this, some of you in your write-ups are a little wacky, it's actually always capitalized at this low. Also, to start out new sentences, it tends to be a good idea to capitalize that. I didn't really go for grammar much on that because I thought that maybe that had been corrected, but literally some of you, this isn't a great big long text message that you're sending to me. Someone wrote LOL in there. We're not 5. So in any case, okay. Nice. By the way, another thing, let's not put our names on them. Look at how nice this is. This makes me want to go through. Again, this could be great. I think there was one. And I bring it up because this was one that made me, I cry very, very easily and quite frequently. Like even that, who's seen the Sarah McLachlan commercial with the dogs? I'm upset for a week. And then there was one recently about a poor young child that passed away and asked to see Santa before they passed away. Did anybody see that story? It's in USA Today and a couple of little pictures. You did? A paragraph in, I disgustingly crying, and then Miss Coy, I go down and say, read this, it's such a whatever. So I'm reading this one from an AP calculator about how their grandma is known for these mashed potatoes that they make at Thanksgiving. Grandma has Parkinson's, so she can't hold the blender like she used to, and it's different to grasp. And arthritis and Parkinson's, which doesn't sound like much fun. She's going through and she can't hold it, so the griddle goes over and she helps with the mashed potatoes. Grandmother starts telling her all of these family stories and blah, blah, blah. Tells her, instead of teaching it to your mother, I'm going to teach it to you so you can carry on the recipe for your children. I'm a mess. I mean, it was horrible. Horrible. I'm violently sobbing, right? This is so beautiful. They did something nice. So they got the spirit of what I was going through. Now, I stereotype because all of you tend to do something good, but what that good thing is, I didn't really put any constraints on it. So the next paper that I read had to do something with, there's apparently a website called Reddit, okay, which I didn't know. I didn't check with tech services what this even was. I didn't know it was like for drugs. And then the kid wrote down, my good deed was I helped somebody build some sort of circuit board on their computer that they were struggling with that I found on Reddit. Now, in terms of overall karma, I'm sure they're pretty close. They both did something good. However, one was definitely not what I was expecting. And that was good, because I can assure you, I started laughing after I was reading this and going, what the hell is this Reddit? Is this good? I'm tracking down the guy that works in tech services and like, is this like code? Are they selling drugs? What's going on here? And they're like, no, it's like a discussion thing, whatever. So, were they very different things? Sure. Your project now, I want you to just close your eyes right now and take a second. Close your actual eyes. I want you to envision you doing that good thing that you wrote. So much. I want you to envision. Think about the smile on the person's face, the amount of effort it took, etc. Now I want you to envision that quantity of goodness that you did. So what we're going to do right now, and it even ties into the scene, we're going to square the amount of good that you just did. Which means technically, if we went through and we square the length and the width, the area of what we've done is going to be 4 times as big. What I need you to do is this. Okay. Your next project, which you're going to have over the break, it was posted to Google Classroom already. I even, is it still up? You guys are what, section 3? Okay. It should be waiting for you in there, in addition to, I didn't assign video because you were already there. Uh-oh. Oh, sorry. Now, to show you that it's different, I changed where it said Thanksgiving into holiday. And as you can see, I put it in parentheses. Proper math notation is always important. Because if I put good squared, you'd only need to do the good part squared. You could simply just do something and then square the good of it. But we want you to take the whole act, that quantity of goodness, and square it. Now, I do ask, please, that you give me full big hit sentences. I'll send this out to remind. I didn't realize that it didn't go out to you. Actually, I'll post it in Google Classroom so you can see it. Some people posted. Some people did a lot of stuff nice. Some people, I can assure you, gave really... This person, by the way, I found out what this was. They tried to insert an image. Okay? You might want to make sure that you get the actual image if you're putting a picture in it. In any case, it was nice to read. Some people did like outstanding work. Some people maybe you could have stepped up to your effort a little bit. But in any case, it hopefully made. Oh, look at this. Now, again, do I need? It's already got me ready to read it. So make yours so you want to look at it. You don't put your name on it. And another thing, some of us got profoundly creative with the envelopes. Is in I'm getting pieces of paper like stapled 17 times on the side. Okay. That might not be the best. If you want, you can just give it with a Post-it note on the top, or wait until you have an envelope. But let's not put the other end of it is let's not put our names on the project, seeing as it's supposed to be anonymous. So that's one thing also to keep in mind. But overall, it was, and I sent it out, again, I thought it went to you all, but I sent it out to at least whoever has signed up through your Infinite Campuses regarding it. For that, I also sent out a notice as to why I recommended the courses for you all that I did. My arbitrary line of separation tends to be at about an 87%. That's not set in stone. Some students have gotten above an 87% and done not as well in pre-calc and Rig. On the other end, I've had students that went below and have gotten exponentially better as they work through more difficult material. It's all about how much you're willing to do. At the other end, everyone got recommended for AP Stats. I really strongly encourage all of you to take that at some point while you're here. You need to make yourself as competitive of a candidate as possible. Most of you, since you tend to be in the top third of your graduating classes, most of you are looking at going to competitive entry colleges, which is different than like DeVry Institute or ITT Tech or some school that you get into by lugging your face. You've got to understand that the schools you're going into are tough. They want to see that you challenged yourself constantly. They want to see that you pushed yourself, that you, even when no one was looking, did you take the more challenging classes? And I assure you this, colleges like to see if you go through some colleges weigh GPA versus the rigor of the schedule. It makes a great essay to write about, if you're talking about that, about how you pushed yourself even when, and you took more rigorous classes, even when it could be even to the detriment of your GPA. And you say, you know what, I took even this class. You could be in Regents classes right now, and you probably would be doing a little bit better because the questions aren't as rigorous. And they get more partial credit. Maybe they do, cupcake party, extra credit point situations. We don't. But some of you don't even appreciate what your mark is. Like, we'll go through, and some people freak out. There was one person that came in for, I got a 79 on, it's terrible. I'm looking at it, I'm like, you made 4 or 5 careless mistakes. On that last test, if you didn't check your answers to see if they got rejected, and you gave me everything's right except the constraints on the question were wrong, that was half of the points. It's the same as what the Regents is going to do. I'm not going to grade you differently. So, you get half of the points then. Because it's a 4-point question. If you didn't do it on the Reach, you lost 2 points, and you're going to lose 2 here. We're not going to operate under different rules. That's what, hopefully trying to give you an accurate assessment set for training which grades. But you all by and large do well. I'm very, very confident that all of you will score, and this is the other end, I think I told you this before, so everybody know what grade you need is a min on the Algebra 2 Reach in order to get pre-calc for dual credit next year, no matter what course you take. Did I say it? What is it? You got 85. That's the state's designation for mastery. That's not what college is. It's actually a little bit less. It's an 83. All of you at a floor need to be getting an 83, meaning the lowest of the low need to be scoring an 83. Because the benefit is no matter what pre-calc you're in next year, it becomes dual credit through MCC. 4 college credits, that means it might meet the math requirement as a junior, and you'll be done. And you won't need to take, whatever it is as a senior. But you get 4 college credits as a junior for taking regular pre-calculus as long as you score above an 83. You won't be, like literally this has happened before. I've had students who sat here who scored an 82 and here who scored an 83. And they both get 90s in the course. What's the difference? This one leaves with 4 college credits and Schrader credit. This one would only leave with Schrader credit. So is it important? Absolutely. Like if you're going to go through and study for something, study for that. Study for your math. It's critical. It really, really is. Now, the stuff that we're going to go through and do today hopefully is relatively quick. It's built off of something that you might have had a little bit of previous experience with to start. So what we're going to do to begin with is this. Before you go into your calculators, by the way, how many did you say wouldn't have signed in there? Half? Let's see. Well, we're getting there. So if you haven't yet, go through and sign in. John Paul, Abby, etc. Sign in if you haven't already. Now, what you're going to go through and do is we're going to answer some questions without the calculator, and we're going to get us to where we need to be. Looking at what's there, take a look at this first question. Before we graph out 3 to the x, let's answer these questions. What's the domain of y is equal to 3 raised to the x power? You can think about the graph, or you can think about it as an input-output problem. What is our domain of this going to be? Y equals 3 raised to the x. What would the domain be in interval notation? We've got 2 people, that's it. Think about what you're plotting, etc. Think about what your domain would be. We're at 3 of us that can tell. I hope for more. Just think about what the graph of it would look like, etc. 4, 5. Every input is going to give you an output. So the domain is negative infinity to positive infinity. Now think about the range, which is the output values that you would get. So think about, make a little bit of a table in your head before we formally make one to give the graph. What would the domain of the, we did domain. What would the range on this be here? It's going to be 0 to positive infinity. You cannot plug in a value in for x and get out a negative value. And you can't get out a 0. Somebody asked this, and we'll go over why something with a 0 is going to be 1 in just a second. What's our y-intercept of y equals 3 to the x going to be? Where would that graph cross the y-axis at what coordinate? Perfect. You get the y-intercept by setting the x equal to 0. So if we do that, this would be the point 0, 1. So we can actually go through and plot that out right now. Here's another thing, by the way, that for me is profoundly frustrating. I don't know how you made it through Geo. There's nothing enriched about some of your graphics. Nothing. Because I'll tell you this, we'll go through little things that I'm not sure if they weren't giving you deductions for, but on the read you lose points for. Let's make a table of values. Again, you don't need to go to the calc to do this out. We're going to pick some x's, so let's do -3, -2, -1, 0, 1, 2, and 3. Let's construct this from a table of values. You don't need your calculator to do this out. Alex M., what's one ordered pair that would be on this graph?
0, 1.
We got that one. Give me another one. No? Plug in a -1 into that function. What's 3 to the negative first? Hands up, please, when you can tell me. This, for some reason, we always get apprehensive on. Do you know? What's that? 1/3 is correct. What's another ordered pair? So tell me the x and then the y. Ben? No. What is it? 1/9. It's tough to change your mentality because you've been doing multiplication for so long. What about another ordered pair that would be on here? We just got Amanda. Alex V., what do you say?
3 followed twice.
Perfect. So 327 is there. Noah? 1, 3 would be there, and this would be 127. So now actually go through and plot those out. Like plot the actual points. So we've got 1, 3, which goes here, 3, 9, which is here, 1/3. Yes, it might be a little bit difficult. You're going to notice a trend that happens, so I'm going to sketch out a graph that looks somewhat like this, and I apologize for the pixelation on this. It's always a little bit off. Your graph should actually be easier than this. This right here is actually something you'd erase and get clear. But what's on my graph that you think most of you are going to forget to give? Hands up, please, if you can tell me. What? Arrows at the end. If the points fit, stop guessing. Some of you give me stumpy, inappropriate, nub graphs. The graph is going to continue out this way. It's never going to go through and equal 0. It gets infinitely close to it. That's called an asymptote, and we have an asymptote line here. The equation of our asymptote for this graph would be what? Hands up, please, if you can tell me the equation of the horizontal asymptote that this graph would have. Absolutely correct. Y equals 0, which is the equation of the x-axis. Now, for some reason, this, in the first class, someone asked it, and I was a little bit, probably inappropriate. I was dismissive of it, because I said, how do we not know this? As enriched students, this is the easiest proof that you can give. Because they said, y is 3 to the 0, going to be 1. What do you think it's going to be? What in your head, what would you conceptualize it as?
0.
You think in your head it would be 0, because how many 3's do you have? 0, right? And that's incorrect. I'll show you why that's false in just a second. We've got 3. Don't put this down. Let's do this. How could I rewrite the numerator? Hands up, please, if you can tell me an alternate way of rewriting the numerator. Seriously? Seriously? What? 3 to the 5th. And I can do the same thing to the denominator. So far I've got 3 to the 5th over 3 to the 5th. And what do I do when I have like bases? What happens between the exponents? Hands up, please, if you can tell me that. Really? Really? What happens between the exponents, Jessica? Nope. Subtract. So I know. That's true. If you didn't get enough sleep this night, what do you think 5 minus 5 is going to be? Outstanding. Now, we get to this. So right now you go through and say, I did all of that. 3 to the 0 has to equal what? Well, instead of looking at that, which is what's causing the confusion, what does this equal or what does this equal? Hands up, please, when you can tell me. What do those equal? What? 1. Again, that's why all of this garbage, when you have these lazy Larrys teaching you saying things cancel. Do those cancel? What do? They reduce, and they reduce down to what value?
1.
You're absolutely right. Now, take a look, please, at these next graphs. So we've got this, and by the way, your graphs should be beautiful. I mean beautiful. They shouldn't curve back in like this. I mean, yours should be much more appropriate. It rides along but doesn't touch the x-axis. It's not difficult. Some of you look like you're graphing while you're getting punched in the back of the head. Taking a look at what's here, we need to determine how the parent function is graphed. What shift is done? Who can describe to me the shift that's done on the parent graph to get the graph that's given an A? Don't go to the calculator. Who can describe to me what shift is done if I'm taking 3 raised to the x minus 3 power? What shift is done on the parent graph in order to make that happen? This is a transformation they should be doing in Geo. Yeah? No. Close. It's going to shift to the right by 3. Now, some of you might have left out and seen what I had here. This would make us move to the right 3 units. Because if it's minus in the input, that's a horizontal left or right shift. And if it's minus, you go over to the left. If it's plus, you go, if it's minus, you go to the right. It's counterintuitive. If it's positive, you go to the left. Hands up, please, if you can tell me what you think that's going to be for question B. What transformation? And if you need it, here's the base parent graph. And by the way, this goes through the point 0, 1. What transformation is done now to give out the 1 and B? Hands up, please, when you can tell me. You're absolutely, oh, careful. What'd you say?
To the left.
Thank you. So this would be over to the left 4. Now, the next one I always laugh at because you act like like there's some sort of firing squad if you get this incorrect. Here's the original graph. What happens when you negate the input? Well, we're going to have to decide. Think about this. When I plug in a 2, that would give me 3 to the negative second power, which is 1/9. Pick something like negative 5. When I plug in a negative 5, it would be 3 raised to the negative 5 power 5 power. What is that causing to happen? You can use a calculator to check, but do some test points, investigate this out. Don't vacantly stare and wait to be saved by others. Think about what kind of transformation this would cause. We've got one person who can tell me what they think. 2. You want to give a guess? No, it's not going to shift it down. So, he's correct. This would be a reflection over the y-axis. So here's what the graph was before. When I negate it, it's going to be a left or right shift. So now this is the case. Notice those graphs will share something in common. They share the y-intercept in common. And by the way, thank you for saying reflection instead of flip. It's going to be a y-axis reflection. You could get that if you plug this in and see what the graphs themselves look like. Questions on what we've got so far? Good, then let's keep going. Looking at the next one that's on your paper, who can tell me, please, what transformation we would do for D? That's going to impact something else as well. No? Close. It's down 3. The reason that it's down 3, when we do this out, the reason that that is going to be down 3 is because whatever is getting done outside of the argument or outside of the input is just a straight up and down slide. The one side to side is the one that's counterintuitive. Now, what changes when we do this? Well, what's the new equation of my horizontal asymptote? Hands up, please, if you can tell me what the new equation of my horizontal asymptote would be. What transformation is getting done in E? Hands up, please, if you can tell me what transformation is getting done in E. We got 1, 2, 3 of us. There you go. So by the way, this was down 3. So this one we'd move up 4. So what would my new horizontal asymptote be? Hands up, please, when you can tell me. What's the equation of the new horizontal asymptote? Y is equal to 4. Now, this is going to be, and I always get a little frustrated with you because you don't get why you get this wrong. But these are very, very, very different graphs. This is telling you to take the negative of 3 raised to the x power. That is not the same as negative 3 being raised to the x power. We'll go through and show you why in just a second. If this is what the original graph looks like, who can tell me what you think it's going to have if you negate that function? We got 1, 2. What's going to happen if I negate this? What type of transformation is going to go on? Sure? You're going to reflect over the x-axis. So here's what my graph looks like originally. Now I'm going to go through and I'm going to have a graph that looks like this. This is going to cause, oh, we should say, sorry, this was up 4, and this was an x-axis reflection. If you negate the entire thing, that's an x-axis reflection. Now, do this, please. Go into your calculators right now, all of you. Go into your calculators right now. And by the way, we'll do this so you don't even bother. So, it's a document-based program. Go in, please, right now to your grapher, and I want you to plug this in. We're going to see the difference between those graphs, not scratchpad. Go into a new document. We're going to go into a graph. So go down, add graphs. And we're going to plug in, let's do this. In Y1, let's do this. Put negative 3 caret x, or negative 3 raised to the x. And, oh wait, do this, sorry. Delete this, put parentheses around your base. And we're going to see the difference. So we'll start off with this. The negative 3, oh, sorry, I'm sorry. You can yell at me all you want. I screwed this up. Put in the one that we started with originally. I'm sorry. So the negative of 3 to the x. I'm sorry. You guys get so angry at me, I can tell. You hate me.
I'm
So, just do negative 3 caret x, because that's the negation of 3 to the x. That's going to be the x-axis reflection that we were looking to have. And I'm sorry, because you're going to see the next graph is kind of cool. Hit enter, and watch what this graph looks like. See how it's, all of these points are connected. It's not a discrete graph, meaning a graphing of individual points. What's going to get weird about graphing a base of negative 3 to the x power? Think about that for a second. Let it play around in your mind. Think about the inputs and outputs that you get. What's awkward about taking the base of negative 3 instead of 3 to the x then negated? What's going to be awkward about taking negative 3 as my base and then raising it to a bunch of different powers? See it? No? What happens when it's negative? You got negative 3 to like the negative power. What would the output be? Or sorry, negative 3 to an odd power would give you a negative output. Because what's going to happen, and think about it, negative 3 to the first is how much? Negative 3 to the first is how much? Negative 3. What's negative 3 being raised to the second power? 9. Negative 3 being raised to the third would be what? Negative 27. And you see how there's that bouncing back and forth. That's called oscillation. So what I want you to do now is this. Go in and put in parentheses negative 3 and raise that to the x power. Now watch what happens, because this graph actually causes the calculator some difficulty. Watch what happens. So it's going through, it's connecting all these points that it's getting, all these discrete separate points, until some magic happens. In just a minute or two, you're going to see something terrific, which shows the oscillating that the graph is going through and doing. We'll get there in a minute. Whose calculator already shows it? Yeah, you'll get there, and this is, just so you know, it's taking this calculator a while to do it. So you can imagine how long it would take you to do it. There we go. Okay? So that's the calculator bouncing in between them. So are they different graphs? Profoundly different graphs. As enriched students, you need to know the difference between the negative of 3 to the x power and the base negative 3 being raised to the x power. Okay? They're very, very, very different things. Take a look at question G. What's happening? What transformation is getting done in G? You know enough to answer this out. What transformation is getting done in G? One person, two of us. What does that constant in front cause to happen? Christina? Close. I'm not going to agree with the dilation. I'll tell you why in 1 second. You know? It's a vertical stretch. Now, the reason being, a vertical stretch only changes the y coordinate. A dilation changes both. Okay? It's just taking it and pulling it up and down as opposed to expanding it by a scale factor. What about h? Hands up, please, and you tell me what h is. 2, 3 of us? Seriously? Sharon, what do you say? Yeah, we could say it is a shrink or a compression. All you're doing then is shrinking down the y values. The x's stay the same. And what about in I? Hands up, please, if you can tell me what's happening in I. Yep. Close. I'd start off and say that it's a vertical stretch, and something else has to happen as well, because the scale factor is 1.5. What? What kind? What happens when we negate everything in the beginning? If it's getting done to the x, then it's a reflection over the y. If it's not getting done to the x, then it's an x. Now, taking a look at what we have here, go through right now, these are what the different shifts cause. A is your vertical stretch, vertical shrink. B is your base. C is going to control the horizontal or left and right shift. And the K is going to control the up and down or vertical shift. What I want you to do now is this. Take a look, please, at question 1. You tell me what that equation is going to be, and you're going to go through and input the answer into your calculator. I'm going to send it out as a quick poll right now. You're going to right now, please enter what your answer is. I just need you to put it in the y equals. Take a look at that first example, and you're going to type in what's the equation going to be. Go into your calcs, please, and put it. We'll wait for everybody so far. Make sure you submit when you're done. We've got 25 we're waiting on. So go through, tell me what the equation's going to look like when I do those transformations on that paragraph. You don't need to put the y equals in. There's already a y equals there. 2 transformations are done. What's that equation going to look like when I do those transformations? So far we've got 4. We can do better. If you go up to the top, to this part right here, the drop down, use like the little, rub your finger on that center thingy and a little handle come up. Click on that drop down and it should say submit. We've got 14 of us so far. We'll wait. Make sure you go through it and put it in. Got 16, 17. We're getting there. Go through and input what's there. What's the equation going to look like? 18 of us. We're still waiting. So. We've got 20. We're still waiting. We're getting there. It's the exponentially slower. We're at 22. We can make a reasonable assumption of where we're at now. Let's see. All right. Not bad. Now, this looks like it's just a syntax issue here. Oh, these are all singletons down here. All right. So, this shouldn't be a times. It should be a minus. This shift was off. Same thing here. This looks like we're missing a bunch. But in any case, this is what it should come out to be. The plus 5s, you've got to remember, when it's plus 5, which direction is it getting shifted? It's going to get shifted to the left. Yeah. So it looks like we're, though, by and large, have a good read on what's going on. Going through now, please. Yeah, take a look, please, at the next page. When we do this last one, I'll bounce down to number 3. What transformations are getting done on number 3 in order to go from the first y equals to the second one. Erica, what's one transformation that you'd have in number 3 to go from the given to this equation? We're going to shift this over to the, no, careful. We're going to have to go to the left 6. And who can tell me what other one we're going to go through and do? Yep. Perfect. Now, hopefully we don't need to really go over these this much because these are formulas that for some reason the Reach is in love with. This exponential concept is really, really critical for you to get. So, there's 2 formulas that you need to make sure that you know. There's one for exponential growth. Now, some of the kids, maybe depending on who you had over at Sprague, but some of the kids experienced this, some did not. There's an exponential, a generic exponential growth formula. Exponential growth, you take the A, which is the initial amount, times 1 plus the rate as a decimal raised to the t power. That's growth. Think about it this way. 10% growth means you multiply by 1.1, not just 0.1, because that would only give you what the growth is, not what a scale of the original is with 10% more on it. Same thing with decay. So let's say, and this, again, for some reason is very difficult for these middle school teachers to understand, if you have an object that has 20% off, they go through and say, well, you compute 20% and then subtract it. That's stupid. You all have, most of you have at least 3 to 5 active brain cells, at least. I want you to think about this for a second. You're not paying, if you pay full amount, full retail, what percentage of the original amount are you paying if you pay full retail? 100%, right? That was not difficult for you to get. If you walk into Kohl's and they've got a coupon for 20% off, instead of computing 20% of the original model, ask yourself this. How much of the original price are you paying if you've got 20% off? 80%. So instead of multiplying by 0.2 and subtracting it, how about we just show you the right way, which is multiply by 0.8? Was it difficult for you to do that subtraction in your head? Let's hope not. No. Growth is plus, decay is minus, and this has real-world amplifications because something that you all will encounter, the two probably most expensive purchases you'll ever make. Number one is a house. The reason why people buy houses is twofold. Number one, the money that you're getting, the money that you pay for the house, eventually you own it. You own some land, whereas opposed to if you rent someplace, you're paying somebody else's mortgage off, but you don't have the headaches of owning the house. So it's a little bit of a split there. But the big reason that you own a home is once it's paid off, you live in it, for 30 more years. What happens to the value of houses over time? Does it go up or down? I don't think they go down. I'm not quite sure where you're living. In Webster, the houses actually go up in value a little bit, like unless you literally do nothing, like let the door fall off the hinge, and when windows break, you just sort of do nothing about that. Over time, they go up in value, okay, quite a lot. And actually, in Webster, we have some of the highest growth in terms of real estate prices because there's a finite number of these homes that you can get in the entire world. It's the number of houses on the lake. Okay? They're not making more waterfront property. So the demand for that's always going to go up in demand. Waterfront houses go up between 5 and 10% every year. They just keep getting more expensive. Whereas regular houses, they go up between 3 and 5%. So waterfront homes tend to be a good investment in general. There's one investment that you'll make that's a terrible investment. The worst that you could possibly make. Does anybody know what it is? Cars never appreciate in value, which is why I always find it's especially young and particularly young guys. They'll buy and I always see them on the highway. They'll buy these terrible. They'll buy like this Honda Civic. The one that I was here, this tricked out Honda Civic. They have some gigantic tail, like a fin in the back. They have this gigantic post-factory muffler on it. The pure tinted windows. They probably spent $10,000. You might as well have driven down the street and thrown $10,000 on it. It's the dumbest thing that you can do. Cars depreciate in value. You buy a $20,000 car, the act of you owning it, 1 year later, it's only worth $14,000 to $15,000 a month. They lose 20 to 30% of the value immediately. And it's even worse. My favorite is, my uncle did. He had money. He bought an Escalade. My aunt bought it. Like a $108,000 car. And I was sitting there, I was like, it's someone's house. I know it's got heated seats. So I was sitting there. And I'm on my phone, and I pull up how much this car would be worth. The time was 2016. He bought it in 2015, so it was the next year. I looked over how much they lost from the year before. So a $108,000 tricked out in great condition. According to Kelly Blue Book, it's worth $79,000. In 1 year, they were so stupid that they lost $28,000 on a vehicle. Done. You never get that money back. Never. Imagine driving around the street, how popular it is. 28,000 singles. That could be your do something good project. Take money and throw it out of a window. Yeah, not trick out a Honda Civic. No, other way around. Now, take a look. Read out question number 1 right now. These are actual questions that you're most likely going to get on the read. Take a look at question number 1. Looking at this, the first thing that most of you struggle with is the difference between writing a model and giving and solving. A model is going to have 2 variables in it. It's like giving out a line. Y equals 5x plus 6. Looking at this, we have to ask this first. Maddie, is this situation described an example of exponential growth or exponential decay? What'd you say, Canu? Perfect. So here's my base equation. Y is equal to the initial 1 plus the rate raised to the t power. Now I'm going to plug in all of the givens. So, Jared, what's one given you can plug in? So it's y equals a, oh sorry, I'm not going to fill in the a yet. And he said correctly it's what? So he did, I'm going to do 1 plus 0.04. We're going to come back to, he gave an even better answer in just a second, but I don't want to lose him. Who can tell me something else that goes into this equation right now? John Paul? What's something else I can plug into this model right now? That's the initial condition. Terrific. So we've got 968t. You don't know what the time is. This function, this model works for any time. It's the model. Now, as enriched students, you actually should be able to give what Jared told us. Y equals 968 times 1.04 to the t power. That is enriched students. This right here you need to understand is your growth factor. Number 1. So what's our growth factor? 1.04. That indicates it's growing. What rate is it growing at? You should be able to look at that number and immediately tell me. Who can tell me what rate that's growing at? Yeah, 4%. Because it's the initial amount 1 plus 4% more. Now, so this is where you should be able to get to. Look at the second question. Use that to figure out the cost in 2010. So how can we use our model now to give a prediction about what this will be in 2010? Why did you plug in 2010? It's years since then. So now you're going to go into your calculator, and yes, this is an approximate answer, which means you use an approximation sign. You're going to go into your calculators right now and compute this out, and you're going to tell me, you could plug in, by the way, my advice, plug in the model, put the bar, and then t equals. Who can tell me, please, what this comes out to be? How much money will it be? Is it per day or per year? Sorry. Yeah. Point what?
3.
No. I know it can't stop there. Who can tell me how far we've got to go on this? 0.31. With money, remember you always go out to the hundredths position. Why is it an approximate sign there? Because aren't there more decimals after that? Is that right? Yeah. So you use an approximate sign. Next one up. Suppose your parents deposited in an account paying that percent interest, find the balance after 18 years. So now, let's ask ourselves this. Is this exponential growth or decay? Nathan? It's growth. Y equals A, 1 plus R raised to the t power. Now we're going to plug in. And what replacements can we make, Talia? Okay. And? Could you immediately bounce into this? Y equals 1,500 times 1.035 to the 18th. This right here indicates that you're going to have growth at a rate of 3.5%. What does that amount end up being at the end? Who can tell me? What amount do we get at the end? One person. It's like we all have broken fingers. 2, 3 of us? Come on. Abby? Point what? 2, 3. Okay. Is that what we got? And actually, I'll say this. I wouldn't put the, this is me being nitpicky, I wouldn't put the approximate sign in there because if you went in, the bank wouldn't truncate the bank wouldn't say it's this much, so we rounded it to this. Okay? It's the same thing when you go to the gas station, and somehow, for some reason, they always put that little 0.9 at the end of the gallon. We don't know why. There's not 1,000th of a cent you can give back. Taking a look at what's here for the next one, read out number 3. How many of us have taken chemistry, or who is in chemistry now? Hands up. Okay, terrific. You've done some work with half-lives. Is that true? Okay. That's something that you've done. That's an exponential growth or decay. In this case, it's a decay over time. This is the model that Algebra uses. I'm not sure if they use the same one, but you need to copy this formula down because it's expected that you'll know it. Again, you could get asked it, and it's expected that you would know it. Now, and some of you might have even had this. The reason I bring that, I don't want to just make it a morbid example, but even my sister's going through this now. She has thyroid cancer, and they remove the tumor, and then they have to do radiation. Now, she's got a little bit of a warped mind. She can't get the radiation. Who here has had a relative that's had, or knows somebody who's gone through cancer and had the radiation? Okay. When you have, my mother's had it, my stepmother's had it, my grandmother had it, they all had breast cancer, my sister ends up getting thyroid, and what ends up happening is you get the radiation, and then you can't be around people for a certain amount of time because you are a radioactive element, or at least your level of radioactivity is not healthy to be around. So we've got to go through, and between my sister and I, my other sister and I, we've got to go through and take care of her son, and we've got to take care of her cats, and the whole deal. And she deemed it necessary to point this out. It's for 2 weeks. Just so you know, that means that I also have to shoulder the full brunt of having to deal with my mother on my own. Normally, it's nice if you can split. We got a phone call from her, or maybe send it to voicemail. She'll call someone else. But now I have to take on the full brunt. So I'm saddled with dealing with my mother on my own for these 2 weeks. But in any case, this is a real situation. If you go through and you have radiation, you can't be around. Does anybody have a relative that was in a situation like that? You couldn't be around them because of the radiation? Yeah. And it even happened, I think, it might have even happened, if I remember correctly, there was a time Mr. Kinsey had cancer, and when he had his radiation, I think there was a time that he couldn't be around you for like a certain amount of time. But in any case, this is a real world thing. Like if you go to an oncologist, they know all about this, and if you're going into biomed, this is something that you'll need to be very, very in tune with. Take a look at what's there. What can we fill in, and how much iodine isotope would be left after 16 days? What replacements could we make in for this? Anna, what do you say? What's that? 16 is T. Yep. Who can tell me something else that we can go through and fill in? Here. Okay, so we'll put an 8 there, right? And what is the initial amount? What would our initial amount be? 12. So now I'm going to tell you this. You might want to run your calculator because this looks scary to you. It's not. What can you simplify out right away that's there? Hands up, please. Yeah?
16 over 8.
Okay, so this is A is equal to 12 times 1/2 being squared. What's 1/2 squared? Hands up, please, if you can tell me that. And again, this is you getting better with actual math. Yeah. 1/4. So now, boy, I need the calculator for this. What's 1/4 of 12? Or to teach it to you like a middle school teacher would, we have 12 slices of pizza, and someone takes 1/4 of your pizzas. How much did they take? Yeah. 3. Boy, they love the pizzas for some reason. Now, we're going to do this because this is going to get you actually ready. These are Algebra 2 questions, taking a look at what's there for this grouping. Which one of these represents exponential decay? Meaning a decrease in value over time. Take a look at question 1. I'll tell you this right now. The easy way to do it is to identify what the base is. If the base is going to be greater than 1, it's growth. If the base is going to be less than 1, or sorry, between less than 1 and more than 0, it's going to be decay. All I did was switch those around. Okay. All I did was get them in the right form. Now, the problem that we have is we ran a little bit long. What you're going to do is this. If I'm you, and especially for those of you who actually want to excel and do well, I'll actually try to send this out through Google Classroom, through Remind. Do you want it through Remind or Google Classroom? I can't remember. Classroom, all right. I'll post it in Classroom. This question got done in the other section. The other thing that you need to do, we didn't have an assessment today at the beginning. We've got one here you can go through and complete for homework. This right here is your homework. The assessment, it's 2 questions. 2. Make sure you show out your ouch and make sure you're answering. The other thing, let's not go through and crinkle up those papers. And maybe if we can keep any form of staining from happening to them. It's always a little bit scary when there's some sort of dried up stain on them. Thank you. Have a wonderful rest of your... Do we see each other tomorrow? Oh, thank goodness. I was so nervous. You were so annoyed? How can you be annoyed with all our quality time together? I'm excited. Abby, are you excited? I am. How about we do this? We'll have a Christmas themed test. Please. Yep, and I'll put little everything will be the height of the Christmas tree. No one brought anything. You guys are really great. I was hammering and I forgot. Yeah. I forgot. Terrible. I'm so disappointed in all of you. We should have had a treat.
You sound like my mom.
Yep.